Hey guys, welcome back to Chris Campbell's Analog Life, and this is going to be a video about leveling the mill and adjusting for all the different tolerances. Now the difference here is there's a bunch of videos by Jay Herzog online which are really great, and that's actually how I learned a lot of this stuff. The difference is my mill actually came from the factory, and it might have actually been him that was leveling it. So this thing's actually pretty well in tolerance already, but I really wanted to be able to pull it apart, see how it works, see all the different adjustment mechanisms, because then if I start seeing, when I actually start measuring the squareness and how in tolerance it is, actually, so I can adjust the X and Y table if I need to, and then the Z axis as well. So yeah, this is just going to be going over all the different adjustments you can do and how it actually affects the mill, and then I'll put everything back together and hopefully it works, and hopefully it'll be in tolerance. This thing's pulling apart already. I've already seen it's in really good shape. I mean, it's a really nicely put together piece of equipment. You can see there's a lot of quality, there's a lot of heft to it, which I always like in equipment. So yeah, hopefully this is helpful for anyone else that gets a new mill. And if you want to see what it actually is, the Taig mill and everything, there's actually a page on chriscampbell.com that shows all the equipment that I bought and has links to everything if you're interested in doing your own. Alright, well, let's get to it. I've already leveled this thing once and adjusted the wide gib once, but I didn't have the sound on the video. So I'm not sure actually if I made it worse or better. I think I made it worse, but basically you try and figure out if there's any play. First, you need to make sure that the mill's moving okay through the axis. Make sure it's moving on its own okay, or see that the Y table is actually sliding well. And this one's okay. It's kind of sticking in the middle. It's the only thing I'm really worried about right now. Problem is, if you loosen up either side, if you loosen up this one, then it gets a little looser on this end. If you loosen up this one, it gets a little looser on this end. This one actually already is a little bit loose, so kind of got to play around with it and try and see if you can still get it to move even though it's tight. See, I just tightened that down, and now this thing is just really tough to move. You kind of knock it loose, but yeah, it's too tight already. See, you can kind of hear that now. So it's kind of this delicate balance of tight enough, but not too tight. See that now? That moves better, but yeah. This one moves okay now. See, that's too loose in the front then. I've been doing this for an hour now, trying to get this right. Use a soft blow hammer to loosen them up, but see, you can definitely hear that in the front now. That's way too loose. Tighten that down a little bit. Still moving okay. Yeah, this is already too tight. So basically, though, you too loose again. That feels better. There's also lock washers on here you can tighten up when you're done. Alright, so on the X side of things, so this is the X table, and this thing slides back and forth. This is a little tight right now. I'm not really sure why. You can see, if I pull this thing all the way off, there's a the X gib here. It's actually this brass piece. It's kind of slanted. I think I showed it before. But yeah, so I need to be able to get the X table not only on here and moving freely, but also to be able to then be able to also make sure it doesn't move too much once I shake it around. Alright, so got it on there. You move it back and forth, just like in the Taig videos. They show you to take it all the way to one end and then kind of feel here, and there is a little bit of wobble still, and that's what kind of worries me. This side, oops, sorry, this side not so much. So the left side's good, the right side not so much. So I'm going to try and tighten up the right side. We'll see if that helps. Let's see. See, I already scratched up the table a little bit. See, that took it way out. So once I tighten this, actually, so what it does is there's a screw here, and because of the shape of this thing, it actually pushes out this way, which isn't great. I don't really like that. And obviously now the mill doesn't move at all, so I can push it back in. So the weird thing is, it also, you can shift this the whole gib actually slides one way or another, and because of the angle of it, that actually determines how tight the mill is in general. So I gotta move it again. And I think I really want to move the whole thing down this way, because it seems like because the big end is here, and because the I know this probably doesn't make any sense, but because of how this piece is cut, this left piece, because it slides back this way, I think if you move the whole gib down this way, it actually opens up the entire space. So let's actually try that. The left side is unfortunately really good, so I hate to move it, but at the same time, sometimes it's necessary. Tighten this side up. Alright, now it's still moving. No, it's moving even better now. That's good. I did end up putting a little bit of oil in here. I don't know if it's the right type of oil. I need to actually check into that and get a better way to apply it. I just kind of put it on my fingers, but you can see the Y table moves really nice right now. The X table is moving pretty well too, I guess. But the other test is, yeah, it's still got some wobble to it. So, like I said, this is all based on the Taig video, so. It's got a lot of give to it. Oh, that's better. Alright, so I think that's probably as good as we're going to get right now. Oh, Jesus. Kind of get in there and loosen it up. That seems to be moving okay. Hopefully that's good enough. If not, I'll adjust it later. I mean, that's the thing. Like, I figure, what with how much I'll be using this thing, I figure I'll pretty much have to, clean it off and take it all apart eventually anyway. So if it's not working great at first, it doesn't really matter too much. I just need to be able to get it good enough so that I can cut anything, which right now, obviously, I cannot. So it looks like we're good enough for now. Let's move on to the, what's next? Well, let's see, we got the Y table on here, we got the X table on here. I think we can start getting the Z axis up and running and start aligning that. Cool, let's get this on here. Well, I skipped ahead a little bit here, and I ended up putting the lead screws back on. This thing does move, you can see, both directions. So, it looks like it's okay. Like I said, it's probably just good enough for now. I'm glad I know how this stuff works now. I know where the adjust points are. And it's not perfect, but I'd really like to get to the point where I can actually mount the stepper motors and the Z-axis. I think Z-axis will be next. And then we should be actually good to start putting the stepper motors on there. So I'm looking forward to that. I'd really like to get this thing. It'd be a good accomplishment to get the steppers, being able to jog the whole thing by the weekend, end of the weekend. So I'm going to work on the Z-axis next, and then stepper motors. So this is the Z-axis. I ended up cleaning off. There was a little bit of rust on here. I tried to clean most of it off. I oiled it up a little bit too. Got it nice and clean. So yeah, I might have scratched it a little bit. Hopefully not too much. But I want to get a nice clean connection to the mount on the back of the machine. That's that big screw that was going through the bottom here. And once I have this all connected, then I'll actually remount. I don't actually have any of the hardware on the top here. But man, this thing is beefy. You can see that it's a big steel beam here. Then there's a couple weld points, block of steel, and then a couple pieces of what I assume to be aluminum here. And this should be pretty precision in terms of the straightness. I'm sure they precision ground the side of this down so that it moves along the Z-axis nicely. So So let's mount this thing on here. I think the back should be relatively clean. Probably wipe that off again. This is the Z lead screw. So wipe this thing off. Problem living in a house with a bunch of dogs is that the dog hair gets everywhere, including anything oily. So there's been a couple points here. I mean, even my clothes. I'm sure that I'm tracking it down here, but you know, you get a sticky surface, or really anything that can adhere to, and you'll find dog hair on it. So, let me get this on here. Now this I'm just going to put on here loosely because so there's a big nut here, and there's a washer as well. I'm going to put this on loosely for right now because I'll actually need to readjust this once I have that other piece back on here. I'll need to readjust it for squareness. I can do a quick measure of squareness here just against the axis, but it's really the spindle that matters. So you see there's a little bit of a gap here. No, that's not a bad measure, I guess. Could be a little better. And again, this is just against the Z table, so it looks okay. Yeah, it looks okay right there. Let's tighten that down a little more. I've just been using a crafty little adjustable monkey wrench here. But you know, it's not the best wrench, but it's nice for when it's you got a lot of different sizes to work with. Yeah, looks pretty good. And again, that's just for the actual stand. Part of me keeps looking at this stuff and thinking, boy, it'd be nice to have a really big piece of machinery. I'm sure it's even harder to get that into tolerance, but you know, that all happens at the factory, and it's not going to move much if it's straight up welded. So, all right. So Z-axis is there now. Should be relatively solid. Feels pretty solid. Looks pretty square. I could even relatively level with the 90 degrees to the ground. Again, some of that could be the table. The table's not perfect, but what really matters is being square against the XY table more than the actual table. I see. I've already found it. Yeah, it was the wrong way. Yeah, that's better. Alright, let's stick with that for now. Alright, and this I took off earlier. This is the spindle mount. This has the same kind of thing. It has a Z gib here. This brass piece is the gib. It has the same kind of adjustment mechanism as the XY table with these kind of this washer around this one screw here, and that goes on both sides, and it slides up and down. I'm not going to try and adjust this. I'm just going to assume it's good, but it's probably a dumb assumption, but I'm getting to the point where, you know, I've already said a couple times that I'll fix it later. Alright. Just wheel it on here. Alright, look at that. Slides up and down real nice. Probably needs a little oil, but yeah. And then this lead screw actually has a different type of mounting bracket on it. This looks like some kind of black aluminum or something, but this actually mounts right directly to the Z-axis itself instead of like these where it's a plate. It's actually more of a block. So you can see the block there. Let's see if we can get this on here. Also, one thing that I was running into before that confused the heck out of me is when you put the lead screws in, they actually screw in backwards from what you'd think. And the reason being that, okay, so I think that if I'm turning something, you know, righty-tighty, lefty-loosey, right, I think righty-tighty, I'd actually be, that the screw would be going into the actual lead screw nut. You know, so if I'm turning the lead screw to the right, you'd think, oh, okay, well, then the lead screw is going to be, right, sorry, if you're turning this to the right, you'd think it'd be going into the lead screw, right, because you're righty-tighty. In fact, it's actually the opposite threading, because what you really want to happen is you want the lead screw to move towards you, right? So if you're turning it to the right, maybe I'll get that backwards again. Oh, jeez. Either way, I was clueless about what was actually going on there, so it's just kind of a weird convention. So you can see this line right here. This is from the Z-gib going up. That's from that piece of brass, and it goes up and down. All right, so now we can check this levelness, or the squareness rather. That looks pretty good. You probably can't even see that, but on this side, that looks pretty good as well. Ooh, I can use my little feeler gauge. So there's at least the two thou spacing here, if we want to. Looks like that might have leveled it up. I probably need to tighten that up in the back some more. Yeah, that looks pretty good. So that's pretty square. So we've gotten to the point where Z is actually moving. That's all secure. Y table's moving okay. X table's moving okay. So what's all left is the switching over to CNC, which is pretty exciting. So I'm going to pop the nuts off of here, and then put on the couplers, and then got to get the covers off of here, and then put the secondary coupler onto the stepper motor, and then attach the stepper motor to the other coupling on here, and then mount the whole damn thing onto the front of this. So we'll see how this goes. So here's all the different parts. What we got here? All came packed in this thing. So this is the coupler that will go onto the. This will go on the stepper motor. It's got a little screw to lock it in there. There's the four. Sorry, lighting kind of stinks. The 4 alignment bolts, and they give you a little bit of tubing in order to actually cut that to length, and then you can shove these in here and line it all up. You see that fits in there real nice. Then the coupler is actually what goes on here, so we'll put that on there. And then this whole thing actually, sorry, there's 2 things here. 3, maybe 3. Yeah, sorry. There's 3 things. This actually screws on. This screws onto here now. And then this actually mounts. This is the plate that mounts to the front of the stepper motor. You see this stepper motor has 4 mounting holes here. All right, I'm most nervous about this. I'm not really sure why, but I'm pretty nervous. I'll be able to figure it out, I'm sure. All right, so this is a half-inch wrench here. Alright, off of there. I'm pretty sure this came with a bunch of screws too. I'll have to find those. But, oh, look at that. Oh, there's even a little, that's nice. There's a little alignment notch there as well. I don't know if you can see that. A little alignment notch. That actually lines up with this thing here. I did not realize, but that probably helps. Yeah, that definitely helps. That'll help get some torque on there. Alright. Pay no attention to the man with the weak fingers. You know, scratched up CNC machine. There's something called backlash, which I don't quite understand yet. I think it's actually from the motion kind of fighting back against it, but yeah. I'm sure I'll figure that out. You know, you see it written in the forums everywhere too, but I'm not sure I quite understand it yet. Man, it's crazy. You can't can't just unscrew this thing. You think you'd be able to, but you actually have to have something in this. There's a slot here where you actually need to have something in there in order to turn it. Boy, my camera work sucks. Finally. Whew. Yeah, see, this is a compression. See, it's actually got a split there. Oops, sorry. Actually got a split, so when you put something in and you push on it, it actually opens up a little bit more. Alright. See if we can't get this open. Yay! Yep. This is going to go on like this. See, and this says the same thing. This is the same split fit. There. Alright, I need to actually figure out how to put this on here. Let's see. First thing I need to do is get this on here. There's actually directions on this thing. Oh yeah, look at that. There are directions that came with it. Nylon tubes. Yeah, so they actually want the important thing here is it says tighten clamped to shaft so that shaft end is flush with bore surface. So I think what that means, you see inside here, so you see inside here, they want that's the end of the shaft on the stepper motor. They want that to be flush with this surface. Oh, now you can see it, of course. So I think I actually need to adjust that a little bit. Okay, so the next step is to actually hook up the now coupled stepper motor to this coupler. We actually want to put the tubing in here. So this is what I was showing a little bit earlier. So these are flat on one end, tapered on another, about 3/4 of an inch long. The idea is that you want to do I was really confused about why the heck you want to do this beforehand, and it's because basically when you're mounting the stepper motor, because of all the other hardware here, it's going to be a blind mounting. So what you want to do is you want to actually line this up now so that you can make sure that the distance is correct. So it looks like it's about right. You want it to be close but not too close, and you want basically you just want it to be the same distance all the way around this thing. And I've got a little bit of gap, so this should be good enough. So yeah, that's good there. And what we'll do now, so we need this piece on here. Oopsie, last one. These look like they're all about the same right distance. So this is going to go on here a couple turns. Okay. Now we're going to actually mount this onto here with a couple of screws. Hopefully the taps are in the correct direction. Oh, where did those go? Those are in the box. So those are probably here. Alright, look at that. Beautiful. Oh, man. I just realized they actually gave me a bunch of Allen keys. That would have been a lot easier. But, let's see. That's weird. Ah, there we go. I actually couldn't push it all the way in because this black piece wasn't screwed in far enough. Oh, since I'm a drummer, I'm always inclined to never go around clockwise. And when you're putting on drum heads, you actually do it in a star configuration. So if there was 6 connections here, you'd go 1, 2, 3, 4, 5, 6. Right? You'd actually go around and you go across each time. So 1, 2, 3, 4. Kind of like how you draw like a 5-point star. So that's always kind of my inclination to do with these things. I think it's nice because then you don't, if you do it 1 and then 2, you could get like a big kink over here, and then you might end up stripping screws on the other side. So I always try and do that anyways. I don't know if that's actually what I'm supposed to do, but it's weird because it feels like, when this thing's driving, that it would be all the way around, but like that this would actually kink itself, but hopefully that's not the case. I think that's what this is going to help with. This is what actually tightens down here. Okay, it's definitely too tight there. I'll back that off a little bit. I'd like this to go down. Alright. So, put this on here. Hopefully, this is actually what holds it all in there. It's weird. It's weird that like one little set screw here would determine how much this thing holds on here, but it does feel pretty solid. I think there is only one thing to try here, and that is to actually step something. Let's see if we can do it. Alright, here we go. Moment of truth. I got the computer fired up. I got this thing on. Let's see if it works. 3, 2, 1. Yeah! CNCing! I was inspired by the Norwegian that found a candy bar. But yes, got one going. It actually moves. This is exciting. It's gonna freaking work. I love it. Alright. I don't really know what happens when you run into stuff, but I'm sure it stops eventually, right? Well, I thought at first I understood why those little plastic things are in here, but I'm pretty sure I didn't actually get it, because I think these are the only thing that's actually translating motion from this to this. And I'm not really sure why this is. I'm guessing it's because these are flexible and they have a little bit of give to them, and if you crank it too hard, like say this thing gets stopped up, say say it hits the bottom of the plate, this will just break the tubes, kind of like a linchpin inside a, like a yoke. I think that's what it is, but I thought I had to kind of call that out. I'm almost done here, and I'll show you the final product once it's all together, but I was really confused at first. I really didn't get that. That's how this is happening. So, and this is pretty rigid tubing too. There's a little bit left, I'm guessing, but this is pretty rigid tubing. When I saw it in the demos, I thought it was just like a straw, but this is pretty solid plastic. So I mean, it is very capable, especially when it's cut short like this. This does translate motion very well, but I think that's the only thing that does it, which is really weird. Because I know I used to wonder that too, like how you actually got a stepper motor to actually translate motion, because when you see stepper motors online, you only ever see the shaft on there. You never really see why or how it actually hooks up. And you think about other types of motors and how it all... I'm not very mechanically inclined. I shouldn't have this thing at all right now. But yeah, so I think that's it. If I'm wrong, be sure to let me know. People always do. Alright, I'm going to install this, and then I'll show you the final moving product. Alright, well, they're all hooked up. Here we go. So, yeah, it's working. These things are still making some weird noises, but I reached my goal for the weekend, so I'm going to shut it all down and get back to it later. So, next up is probably more measurement, making sure this is all square still, doing some sweeps of the table, X and Y table, and then mounting up some stuff and starting cutting into it. I got to mount the spindle too. Thanks for watching.